Hi guys, my name is Henri, CEO and founder at Streamr. It's my second time on Bitcoin Wednesday. I can see some familiar faces here, so great to be here. Last time I introduced Streamr to you, I did a live demo, and after the talk I got a hug from a person in the audience, so I came back. A lot has happened in 2 months. We've built more demos, we've announced a token launch, but most importantly, we've made new friends in the ecosystem. And to avoid repeating what I did last time, I brought a couple of friends with me today. So we're going to do a very special super combo of talks today. As a very special guest, we have Grzegorz from the Golem project. We announced official collaboration with Golem since I was here last. And we also have my colleague Risto from Streamr. We're working with a very early stage project who's planning to use Streamr for saving the planet, which is an okay use case for Streamr, by the way. Right? So, and in the end, we'll have a kind of like a panel discussion on the Streamr Golem collaboration, and you'll be free to ask questions about everything that you hear today. But I'll begin with a very short introduction of what Streamr is, right, in a few minutes. So Streamr aims to tokenize the value in real-time data. So let's consider, for example, a self-driving electric car. Now, to deliver the best passenger experience, the car constantly needs data from other machines, such as traffic congestion information from other cars, electricity prices on nearby charging stations, weather forecasts, and so on. Now, Streamr provides a single interface for receiving the data and paying for it, using a cryptographic token called Datacoin, which lives on the Ethereum blockchain. Now, this effectively makes data streams tradable by both people and machines. Now, the car can go in and find the data that it needs and pay for it. And now, in turn, the car can sell the data it produces, such as traffic information to other cars, road condition measurements. Whoa, now we're talking. What happened? Road condition measurements to other cars, traffic, okay, so road condition measurements to smart cities and passenger blood sugar levels to advertisers and so on. So this kind of data stream economy is born, right? Now, Streamr is implemented as a decentralized peer-to-peer network for data delivery. A data source can connect to any node in the network, publish a new data point, and it instantly gets delivered to valid recipients. The network scales up to billions of events per second, and it scales horizontally using a clever sharding scheme. It also communicates with an underlying blockchain for security-critical operations, such as value transfers and access control. Now, decentralization is achieved by allowing anyone to run a node on the network and earn tokens in exchange of bandwidth they provide to the network. So effectively, the network is run by its users instead of giant corporations, which means that you own, control, and monetize the data that you produce. Decentralization also makes the network robust against attacks and node failures. Now, in addition to the scalable messaging infrastructure that we're building, we're also building 2 applications. A marketplace will allow the data producers and the data consumers to find each other, kind of like an app store for data streams. Raw data is usually not very useful as is. Some kind of computation is usually needed. For example, combining different data streams, doing aggregations, doing filtering, doing visualizations, connecting the data to the blockchain, connecting it to legacy systems, and so on. And to make this easy, we're also making the Streamr engine. Now, the Streamr engine has a user interface called the editor, which is based on visual programming, and it looks like this. So last time I was here, we actually built from scratch an IoT data-driven incentivization system for public transport, which aggregated data coming in from IoT sensors and forwarded that to a smart contract as a basis for payment. So this is up and running. You can go and sign up and start using it right now. We make your streams come true. Thank you. I will now hand over to my colleague Risto. Thanks.
Tuossa ei nyt näy ne noutit. Tarvitsetko?
Mäkin mieluummin tarvisin ne tietysti.
Otetaanko IT-paussi vai mitä nyt? No en mä tiedä, vedän vaan lonkalla.
Joo, just. Okay, hello everyone, nice to be here. Nice to see so many faces. Okay, hello everyone. It's better. Nice to be here. Nice to see you all. This is about saving the planet with Streamr and some of our friends. And sorry. Yeah, and this kind of reminds me of a story in Wired in February this year about 10 ways to end the world. There's 10 different things which can happen, kind of ranging from AI taking over or kind of autonomous arms or war machines are coming and killing us, or diseases and things like that. My favorite there was the kind of hypothesis that we are all in a simulation of somebody much smarter than we are. But one thing in there, which was not high on the list, but which I believe is important, is the global warming and the climate change. And we are seeing this a lot in the news, as is in the US, many other places in the world, Caribbean at the moment. Lots of kind of extreme weather events taking place, and I think these are becoming more and more common in the coming decades. And being here in Amsterdam, I'm particularly, of course, worried, but I know you build good dams, so hopefully you'll be all right. But the kind of moving on, if we manage to do that.
You have to do a dramatic move.
Probably.
I told you.
Yes. So there's some debate of what's causing the climate change, but I think the consensus is that it's the greenhouse effect, and you probably know a lot about that. Kind of a building up of greenhouse gases in the atmosphere. Water vapor is the most important ones, but followed by the carbon dioxide. And we as the mankind are clearly kind of the culprits or the guilty ones for adding carbon dioxide in the atmosphere. For centuries or for kind of 500,000 years, the level has been very variable but kind of in control. But since 1950s, it's kind of gone through the roof. And it's really because of what we have done in the industry and in the cities. Sorry. This is not going well.
Just use the space bar from
I
now on.
think.
Tässä.
Yeah. Okay. I'll put that aside. Question is, what can we do to make the difference? And clearly, there's personal choices we can kind of do, kind of drive less, take fewer flights, and kind of eat less meat and things like that. But the real key really is to reduce the amount of carbon dioxide in the atmosphere. And the word or term for that is carbon sequestration, process of capture and long-term storage of carbon elsewhere. Soil is the kind of a key in there. As it is, there's more carbon already stored and captured in the soil than in the kind of atmosphere and kind of biosphere combined. So if we can do more of that, we'll be in a fairly good shape. Problem as it is that we are currently releasing more carbon from the soil than we are kind of storing in there, and the obvious thing is to kind of change the way we farm. Word for that is something called regenerative agriculture. And I'm not sure how familiar you are with that, but it's kind of a treating land use and agriculture as a kind of a whole ecosystem, optimizing over bigger quantities. Many kind of practices which are already common in, like, say, organic agriculture, working with the nature as opposed to kind of against that. And it's been estimated that all of the current carbon dioxide emissions could be sequestered if everybody was kind of following such practices. Now, by now, you're probably wondering what on earth has this got to do with the blockchain, right? Now, as it happens, we met some guys from a consultancy called Terra Genesis earlier this year through some common friends. And they are asking questions like this: can we incentivize the farming community to work on large-scale regenerative agriculture and carbon sequestration? Can we tokenize the amount of carbon stored in the soil? Can we prove, achieve consensus on how much carbon is in fact captured by different farming practices? There's a number of very kind of clever people in that team. Christian Scherer, Gregory Landau, two people kind of heading that effort. We've talked with them on a number of occasions and decided to kind of give them a helping hand. Ideas are all theirs. We'll do our best to provide the infrastructure, peer-to-peer kind of data delivery, engine for analytics calculations, and kind of a data transport for telemetry data. But the ideas, in a way, are kind of pretty simple in here. What you can do already with existing sensor technology is that you can measure quantities in the soil, in the roots of the plants, plantations, which are correlated with the amount of carbon sequestered. And you can do this in kind of near real time. So effectively, what you are doing is measuring what happens to the carbon. Clearly, there's lots of kind of science behind that, so it's not a trivial problem. But that's where you kind of start from. Then you need to put those numbers together on a calculation platform to kind of really arrive at the estimates and to show that you've proven the amount of carbon sequestered in the soil. And how that ties into the blockchain is that you create a digital token which is given as a reward or as a bounty to those people who can make the difference. So kind of farmers, farming companies, governments, organizations who can kind of put up the bounty and kind of direct the effort of sequestering carbon where it's the kind of the most efficient or the marginal benefit is the highest. So in those kind of 3 steps, you can get to a world where you are rewarding the amount of carbon sequestered, slowing down, eventually even reversing global warming. Beautiful thing about that is that you don't need to be a kind of a farmer or expert on this. If you care about the planet, you'll be able to, at some point, buy some of the token, put that as a bounty, and reward the efforts of those who can make the difference. Clearly, there's a number of details in there. It's a very ambitious undertaking, not a trivial one in any way. There will be lots of work on this, on economics, token design, pilots in various locations, with the sensors in, let's say, cocoa plantation in Ecuador, things like that, just work out the mechanics, how this actually works in practice. But we like the use case. It's great for us in terms of kind of data transport, the data market, things like that. At the same time, it allows us to kind of help save the planet. So it's something we like doing. Thank you. Any questions at this point?
Yes. Is there anything between this project and the Juju project? Have you heard of it?
I'm sorry, I just couldn't.
The Juju project, eliminating the global warming.
I'm not sure if it's a usual project. Is that your question?
Jojo, I guess like Juju.
Okay.
Jojo is another project he's referring to.
Yeah.
To what you're doing and seeing whether you know.
Sorry, fine, okay, yeah. Sorry, I'm not familiar with what they do. We work as one team. I'm sure there are others.
Yeah, of course. Yeah. But you said that you are going to reverse the global warming process. So is it reversing it? It makes sense like you're going to make coal or something like this, or no? You want to eliminate or decrease it? Because using the term reverse.
Reverse global warming.
It makes it that you're moving just in a reverse way.
Okay, probably we don't want to make the world any colder either, if that's what you mean. I think we want to kind of get to an equilibrium.
Yeah, that's the thing.
Okay. I think what we'll do is, because we're going to do a panel with all you guys and then have time for questions
that's fine.
all together. And I know that there's a link to the Golem platform, so let's invite Grzegorz up, one of the original engineers for Golem. Great to have you here as well. I think most of you guys have heard and are familiar with Golem. It's the decentralized supercomputer based on blockchain, and interesting to have these two companies working together as with one party really providing the computational potential and the other side on the streaming and real-time data. So I think it's going to be great to hear an update on Golem. I think that also Golem had a lot of attention when they initially launched it. Has since been there's been a lot of anticipation since then, and so I think we're very excited to hear what you have to share with us, Grzegorz. Thanks very much.
Thank you.
Yep.
Thank you for inviting me to these talks and speeches. I'm Grzegorz. I know that it is difficult to pronounce, but I can teach you later. Just call me Greg. Okay, so I'm a senior software developer in Golem, and as you said, I'm here to give you an update, but before that, I think that it would be good to say what Golem is. The question is, are you familiar with Golem? Do you know what Golem is? No. Okay, so my plan was to start from blockchain, and I think everybody knows what blockchain is, or still nobody knows. I think we are still on the way to understand blockchain. We know that it is the mechanism that allows us to transfer some digital property between two parties without third party engaged. And that's why it created Bitcoin, as we know. But after that, Ethereum came, and now we know that blockchain, it is not the only money, but also we have something more here. We can write so-called smart contracts. It is programs that are irreversible somehow. Why? Because they are transferred between users of this blockchain, and we cannot reverse them. So we may think about advantages and also about disadvantages at the same time, because each party introduced there cannot be reversed. So it is innovation and also a warning. Okay, so now I think I can give you some metaphor about Golem, because blockchain and this irreversible technology give a promise to develop something like Golem, super powerful computer. So the metaphor is that our computers, I mean PCs, laptops, data centers, these guys are like our cars. All of them are stacked at the parking lots. And I think they are stacked more than 90% of their lifetime. Or even they are in traffic. Usually there is only one guy inside, which causes, as we see here, traffic jams. So bringing this metaphor to our computers, we do not use them efficiently. We usually run one program on our laptop, on our computer. So how to use them in efficient way? There are more problems. We know that there are a lot of technologies. We have different kinds of technology here, from cloud to data center. We have laptop. Of course, we have also different kind of the chips, different software. It is not good thing for software developers. It is difficult to transform the software from one piece to another. Why? It is incompatible, usually. It is a big problem for us to use different technologies. Today, I think it looks like that. Okay, so Golem was developed, the idea was developed because people, computer users, do not care about technology. They would like to have the problem solved, not how this problem is solved. We don't care what system file we have. Now we have a lot of file systems, NTFS, X3, X4, FAT32, and so on. Why we care about these file systems? Why we know about these file systems? It is because we have to know about them. Okay, so Golem is to solve all these problems. Golem was created to delegate our problem to other computers by partitioning it and solved independently. After that, the solutions are gathered together and transferred to the computer of the requester. So we may imagine the process like this. We have the requester of computational power and provider of computational power. So we can consider this mechanism as an Airbnb for computers, but it is slightly different model because on top of this, we can imagine software developers. This project is open and everybody can join. Everybody can implement the software. The other innovation is that whole the network is implemented in peer-to-peer network. So there is no third party in this process. The computations are done in distributed way. So for the user, it means that they are done faster. And of course, when we consider distributed computing, there is no single point of failure. So to give you some hints, how does it work? Golem is the network of virtual machines when the token is used to deliver some property for calculations done by provider. What I would like to mention here also is that Golem is not the render farm as it is considered by many people. We implement Blender as, and Lux renderer as first use cases, just to show that it is possible to make these calculations in distributed way and make it faster for the user. In future, we consider in the next step to implement Hadoop problems in general and machine learning. So these powerful tools and done it in distributed way. Coming to the collaboration and scaling up the project, it was already announced by Henri that we collaborate. And we find out that our technologies somehow complement each other, because these guys mostly focus on delivering the data, and Golem focuses on computational power. But as we see, Golem cannot exist without delivering the data, and Streamr cannot exist without computational power. So we can imagine these technologies as complementary stuff. Of course, there are a lot of overlaps, a lot of problems we have to deal with. Every day we may define a PhD thesis, and we have to somehow solve these problems to overcome them. I would like also to mention about the other group we started to collaborate with is a friend app. It is the layer that constitutes to unifying software. This software is independent. We can use it with different file systems and with different operation systems. It is not dependent on the computer you use. So we may imagine what Golem will be in the future. You can run your program from the mobile device. At the same time, you can run it from the computer. You can delegate your task to the other computer. So it is some kind of the unification. It makes calculation faster. And it is what is most important to the user, to have the task solved, not the system file one on another system, operation system uses. Okay, to give you some update, what we done recently, so we migrated all the stuff to the Python 3. It gave us some features. We work on wallet management, so it is the part for transferring the tokens, and we try to make it as secure as possible. It is the main goal for us, and I think the main goal for everybody. We also put a lot of effort to the DevP2P protocol. And of course, as you probably noticed, we recently have a new graphic interface. All the stuff can be downloaded from our repository. You can install it now using free systems. It is macOS, Microsoft Windows, and Linux. And it is how does it look like now. So guys, please download it. Please test it. You can join as a requester. You can join as a provider. You can join as a software developer. And I think it also depends on you when new integrations came to life. Thank you very much.
Okay, we thought it would be nice to then have some Q&A both for Golem and Streamr combined. So let's give the, and if you guys could try to repeat the question, since we have a large room, we also have a camera. Yeah? I think I saw the first hand over here.
Yeah.
I'm wondering about Streamr. I don't have any idea how your technology works, so this is the question to you. Is there some way that this technology could be used as a way of allowing individuals to monetize their own data streams and therefore also put their streams off limits to people who will not pay or particular services in a way that would allow you to almost seamlessly surf the web with a personal assistant next to you?
Yeah, so the question was, is this technology that allows people to monetize the data that they produce and only share it to people they want to share it to? This is exactly what Streamr is doing. So even though the data travels in a public, decentralized network, the data that is somehow access controlled is encrypted. So only the intended recipients of the data can read the data. And the data can be basically anything. We're pretty much gearing the system for kind of machine data, data coming from IoT sensors, applications, crypto and stock exchanges, the social media, pretty much everything that has some kind of connotation of time. Usually data that is valuable in time, it's valuable soon after it happens, and then it kind of diminishes the value there. So for example, if somebody breaks into your house, you'd like to know about it soon, but if you learn about it 3 months after it happened, it's no longer valuable to you. And this same same thing applies for many kinds of data in a more granular fashion, for sure. Cool.
I had a question. How would you compare yourself to another projects like RLC? Or would you draw that comparison?
To who?
To RLC.
iExec. Yeah. Okay. So, what can I say? The question was how we compare Golem to iExec.
Yes.
It is difficult to answer this question because these two guys are still developing things. But what we may assume from Golem, we try to do it completely in a peer-to-peer network. So this is, as I think, the main difference.
Well, as you said, new way for machines and people to trade on a decentralized B2B network. How about the businesses, B2B? You focus on that, or no, you want to just make businesses operate?
So, I'm not sure if I caught all of that. I think the question was, is it for B2B or B2C? Yeah, okay. So traditionally, I think businesses like to keep their cards kind of close to their bodies, you know, every once in a while, take a peek. And I think this should change because there's value in the data that is being siloed away. There's value for the enterprise itself, but in addition to that, there's value probably outside the organization as well. So yeah, definitely I see the potential for B2B cases in there. Why not? I mean, why don't, I don't know, why don't telecom operators open some of their data for others to use for whatever purpose? Of course, they open it also for their competitors to see, but if they gain a payment in return, why is that such a bad thing? If you price it right, it should be okay. And of course, you can't publish like personal information, but you can anonymize things, you can aggregate things, and still have the data streams going on in there to create effectiveness and efficiency into the markets and add transparency and cooperation between companies and organizations.
I have a couple of questions. For you, how are you different compared to IoT? How do you prevent data relays? Imagine I pay for data and I relay it to others and also receive payments. And for Golem, can you give an example of the type of requesters? Are we talking about general people, or it's more of a like scientific type of tasks that can be distributed among different systems?
Look at the presentation from the previous time.
Okay, three questions there. How is Streamr different from IOTA? I'll start with that. Yeah, IOTA is a blockchain, right? So they have the Tangle network. We are not a blockchain. We focus on scalable data delivery on a peer-to-peer network. I think there are some overlaps. Both target, I think, IoT as a possible source for the data. I think IoT could be one of the data sources, actually, or the data targets for the data flowing through the Streamr network. So basically what we are offering is assisting people to create real-time decentralized applications or data-driven applications. And I think IOTA is one platform that we should definitely look into in terms of collaboration. I don't think they are that competitive. we're focusing on the kind of data stream economics and buying and selling data and analytics for the data, and they are not. So I think there's good collaboration opportunities and coexistence opportunities. And could you remind me of the second question?
If I relay the data.
Yeah. Classic problem of piracy on decentralized networks where there is no censorship. Right. So yeah, that is a problem. There is no way to prevent that. Basically, we can only disincentivize that. Right. So, for example, if we have the marketplace, which is like a portal for people to find the data they're looking for, it could have some level of curation going on the marketplace. You cannot censor data from the network itself, but you can make it unprofitable for the people who are kind of the pirates in there. So we're talking about the case where somebody buys data and then publishes it for cheaper or for free, and people would go to that data instead. Also, data provenance is very important here. So the idea in the Streamr network is to sign all the data points so you can trust that the data is coming from the origin. Now, if you have a pirate data source, it's harder for you to trust that, for example, data is not being tampered with or data is not being omitted in the process of receiving it and then republishing it, right? So if you have a critical use case, like you're doing algorithmic trading or whatever, would you trust the pirate or would you trust the original source of the data? Say you have NASDAQ in there publishing data and you have the pirate, you know? So it's up to you basically, but I think disincentivization of that and a soft form of censorship on the marketplace will help solve that problem. Plus the trust of the actual consumer, where he wants to put his money into. And there was a third question for Grzegorz.
Yeah. Okay, so answering your question, whether Golem is for B2B or B2C, I think for both. And when we even look for this rendering example, it depends who will use it. It can be used by a person and can be used by a company. And we can also imagine scientific projects on it. Okay. You need Golem network to process it in an efficient way.
Mining, for example.
Okay, we have another question here.
It's a bit of a follow-up to the last question.
Okay.
To IX. So IX has the option to also have more private networks and the public networks. You're saying you're just doing the decentralized part, which is great. And this follows up to another point. Your first application, Linda, and Undergrass Golem. If we take a company like Pixar, for example, if they were to use the Golem network to render their movie, that movie would then be public for the whole world to see before it's actually released, because that's public information. That would be a large disincentive for a lot of people to use something like Blender as a Golem application in this case.
Okay, let me refer to the first part. It doesn't mean that Golem, everybody can join Golem. It doesn't mean that we use only public resources. Everybody can join. I said that we focus to do it in peer-to-peer network. It means that everybody, data center and personal computer, will be treated in the same way. And to answer your second question, it is not true, because you can ask me whether the data is secure when you use Golem. I think it is somehow the same question. When you use one of these big guys now, how do you know that it is secure? Because of the agreement. Here in Golem, the data is partitioned, so even if it is open but not, each node have access to only chunk of the data. So we may assume that it is more safer than any of these big guys we have now on the market.
Okay, that's a good answer. I'm going to go over here because I realize we haven't had any questions on this side of the room. Unless this side of the room wants to leave everything to this side of the room.
Any questions on the collaboration?
Yeah? Okay.
Hi, thank you very much for the James talk and very fascinating and interesting. I was wondering about Golem in particular. So I'm using sometimes scientific data.
Sorry, could you repeat again because I do not hear you.
Oh, is it better now?
Yes, for sure.
Okay, thank you. I have a question about Golem in particular, and that is if I, as a customer, want to have a data set processed, then what is what kind of format would I need to deliver it to Golem to, and what precisely would be different from delivering it to, for instance, the Amazon cloud services?
I think it depends what is implemented on Golem.
On the application.
What kind of format does the data need to be sent into Golem for it to be processed, and then how would it be different from an AWS? Yeah.
The data format. I think we are trying to unify it so the software we implement will provide the opportunity to use any format you have on the market. It is the goal.
Sir, so the question, a follow-up question, similar to what I said. Can I have my So, in terms of the provisioning of computational capacity, and then the consumption of computational capacity. Can you elaborate the similarities or the differences between the way Golem does it and the way Amazon Web Services does it? The differences and then the similarities.
So the main difference is that Amazon service is a cluster of servers which is owned by a group of people. It is the main difference. And the Golem is the network owned by you. Everybody here, everybody can join and provide computational power, storage, network, everything. So it is the main difference.
Okay, I think we'll do last question, and then we're going to change the mood a little bit here. So over here. First.
Hi, so can you hear me okay?
Yeah.
Okay, so I have a question for Grzegorz.
Yeah, okay.
We're talking about self-censorship. You're saying you own the network. You're saying, this is ours. So is there any way on the Golem network to exercise some form of discretion to filter or limit the scope of the types of operations that you volunteer the processing power of your computer for?
So you are asking about joining the Golem network with specialized software, for example, yes? Am I right?
For example, he was discussing, academic work, right?
Yes.
So is it possible maybe to, is it possible to just to limit, for example, say, I only want this within a certain geographical region or within a certain university network or professional network?
We can consider it in that way, but when we are considering the peer-to-peer network, there are no limitations in general. So it usually works like that. But we can imagine the network, which is also peer-to-peer, and as a combination of the computers located at the university, for example. So it is still possible.